Good morning, everybody. Testing of voice over any network has become extremely important for establishing quality of the network, confirming quality of the end equipment, and confirming reliability and stability of the network. In some cases, quality is needed for customer satisfaction and to either increase their customer base or retention of current customers. In other cases, quality is important to hear the conversation. It's crucial when testing emergency services, military-type operations. In other words, life and death may depend on whether I can hear the conversation. While extreme quality is not important in these cases, there's no need to hear the pin drop, the ability to hear a high percentage of the conversation is very important. And with the push from narrowband to wideband or high definition audio in many networks, voice testing becomes even more crucial. Voice quality using PESC algorithm, which is ITU 862, has been replaced with the next generation voice quality algorithm, which is Polka ITU 863. Polka supports both narrowband as well as wideband, and actually super wideband as well. In fact, Polka was designed to specifically handle the VoIP wideband codecs and provide accurate MOS results when testing under these environments. The wireless world introduced voice over LTE a few years back, which provides voice over a wideband VoIP network. With this release and the massive deployment of VoLTE across the world, testing both legacy narrowband circuit switch networks and the VoLTE wideband networks, along with communication between the networks, is very necessary. So testing both the legacy as well as the next generation. Testing wired headsets connected to Skype on your PC, for instance, and phone handsets using a VoIP phone, for example. In other words, any four-wire analog interface is also very important. These analog interfaces are essentially the method consumers are connecting to the VoIP wideband networks. So testing the actual customer experience is crucial in determining the quality and reliability of the network. Finally, as cable and fiber carriers are pushing voice as part of their TV data packages to the home, the primary focus is to allow consumers to continue using their existing two-wire analog cabling within the home. In other words, no rewiring of the home. However, now the carriers are offering HD or wideband voice over their existing two-wire analog lines as part of an upgrade to the residential gateway provided to the homeowner. In other words, the gateway or ATA within the gateway now supports HD or high-definition two-wire analog. So, of course, testing both the narrowband and wideband audio associated with two-wire analog is still essential for bringing quality to the consumer. There are many challenges associated with testing wideband voice and the network deploying wideband voice. On a mobile network, handovers are a big requirement, and the ability to sustain HD quality for the duration of the call. Also, as carriers push forward with their VoLTE deployments, the ability to sustain HD voice between carriers will soon be available. So, VoLTE across different carriers. Right now, VoLTE is only supported within a single carrier, at least in the US. As part of the test, you need to confirm the audio being analyzed is also wideband. So even though the connection to the network might be wideband, or the connection to the mobile network might be VoLTE, this does not necessarily mean the audio maintained is wideband throughout the network. Any part of the network drops to narrowband at any point within the network, the audio would effectively be narrowband at the far end. In other words, the frequencies above 4K would be suppressed. So confirming audio during the entirety of the call is wideband or HD. It's quite important. In addition, for mobile networks, when testing VoLTE, it's imperative to also accurately test one-way delay, since this will absolutely affect voice quality. The bottom line is carriers are looking to replace existing wireless and landline networks with HD VoIP networks to essentially reduce maintenance costs and provide higher quality audio. They want to reduce or eliminate the need to maintain the old legacy networks and just move forward with the HD networks. So GL introduced a product called VQuad around 10 years back, which works with external hardware when connected to a PC for accurately testing voice over a variety of networks in both manual and automated modes. Basically, taking the human out of the loop and automating the entire voice quality process, including generating the call, sending and receiving the voice, analyzing the recorded voice, the whole process. Shortly after the introduction of VQuad, the first iteration of the GL Dual UTA hardware began development. So the Dual UTA is the box that connects to the PC and has all the interfaces. It's about this. It's actually a very small box. So the interfaces that are supported on the Dual UTA include two-wire analog, or FXO, basically simulating an analog phone, four-wire analog, TX-RX. Basically, we can connect to pretty much anything, a headset, PC, whatever. Four-wire analog for phone handset, or the RJ22. We're replacing the handset at the curly cord of any phone. Four-wire analog for push-to-talk support for mobile radios. So not only the four-wire analog, but also the ability to key the radio on a mobile radio network. And also Bluetooth for supporting mobile phones. These interfaces are all controlled via the VQuad software for testing voice quality without the need of external sound cards. So by eliminating the need for an external sound card, incorporating the codec within the Dual UTA, GL provides a stable and consistent testing of any voice network. Also, since the Dual UTA introduces negligible degradation during voice tests, it becomes a means to accurately analyze voice within any network. Not only can the Dual UTA test voice, but it can also accurately test one-way and round-trip delay. It can test echo with the help of the GL echo measurement utility to test signal-to-noise ratio. So all aspects of voice. And when using the two-wire analog FXO interfaces or the Bluetooth interface when connected to mobile phones, the VQuad solution can provide a complete automated test, including call control, voice and delay testing, along with providing a variety of KPIs, which we'll discuss a little bit later, that's included with the entire call process. As a requirement to testing VoLTE over mobile networks, a couple of years back, GL introduced an update to the Dual UTA, which included support for wideband Bluetooth. In other words, the VQuad with Dual UTA could test both narrowband and wideband over Bluetooth. So it can test wideband on Bluetooth, wideband on four-wire analog, pretty much everything except two-wire analog. Now with the Dual UTA HD, we've also provided support for the two-wire analog HD, so all of our interfaces support both narrowband and wideband. In fact, GL's VQuad with Dual UTA HD can support narrowband, wideband, also supporting super wideband on the four-wire interfaces. Along with the Dual UTA HD, GL has released version 8.0 of the VQuadsoftware, which includes a new audio analysis function to show the power level of the recorded voice including if the voice path is available on the network. So that's what you see here, that we can actually show if the what the power level is of the recorded voice, as well as what the bandwidth is, if it's narrowband or wideband. So if we're testing over a wideband network, we can do a very quick test to see if it actually is a wideband network, or if the voice is sustaining wideband. And since this function runs within the VQuad script, so the automated method of running the tests, these errors can be automatically generated and used within the conditional statements within the VQuad script. So for instance, if there's no voice path or the audio is shown as narrowband instead of the expected wideband, the VQuad script can actually take different paths or generate errors. So here you can see the two Dual UTAs, the older generation Dual UTA on the left and the next generation Dual UTA HD on the right, and they look the same. The new Dual UTA is smaller in depth, a little over an inch smaller, so it a bit more compact. And we moved all the audio interfaces to the front. So previously we had, for instance, the PTT interfaces on the rear of the Dual UTA. Now everything is on the front. As you can see, it makes it a little bit easier to use within the field. So we've also included some additional features on the Dual UTA HD from the previous generation, including LEDs showing the GPS pulse per second, so we can actually see if the GPS is in lock or not, right from the hardware. And also a self-test LED confirming proper initialization with Dual UTA, which we actually have access to right from the VQuad, so we can actually turn that light on and off to show that a test is running or not testing. So we provide certain access to the actual LEDs on the panels. As mentioned previously, the Dual UTA interfaces include 2-wire analog, 4-wire analog, 4-wire analog handset RJ22, PTT for mobile radios, and Bluetooth. There's also an interface for GPS in and out. So when GPS receiver is connected, we receive both the lat long coordinates for marking every event, every result with GPS coordinates, and then we can plot them. And we also get accurate timing from the GPS. Now the reason there's in and out is because we can actually put a GPS receiver in the in and then take that same signal from the out and put it into another Dual UTA. So if there's multiple VQuads in a room, we can have all of them having the same GPS from one GPS receiver. There's also a stereo monitor interface on the front, and this is to monitor the two sides of the Dual UTA, left and right. So you can see that there are two sides, side 1, side 2, and all the interfaces on side 1 are repeated on side 2, so they're all fully independent. So you can be selecting PTT on side 1 and 4-wire analog in and out on side 2 and run fully independent tests. And then with the monitor port, you can specify whether you want to listen to TX or RX on side 1 or side 2 for the left or the right ear. So for instance, the left ear you can be listening to transmit side 1 and the right ear receive side 2, or whatever way you want to do it. Now our all-in-one platform, which you're seeing here, this is the VQuad Probe. And this was introduced a few years back, which includes the Dual UTA, the PC running WinOS, and the VQuadsoftware. The VQuad Probe, as you can see, is non-intrusive looking. So when placed on site, nobody really knows what it is, and will hopefully just leave it alone. which is unlike if you leave a PC or a laptop on site, people tend to touch it. So all necessary PC interfaces are provided on the VQuad probe, including a couple of gigabit Ethernet interfaces, VGA and serial port interfaces, and 4 USB ports. We can also support Wi-Fi or LTE connectivity using USB adapters. And with no moving parts and very low heat dissipation, the VQuad probe is great for deploying anywhere, including drive tests. The GPS receiver can be connected directly to the Dual UTA interface, providing the coordinates and accurate timing during the drive test, and full remote control of the VQuad software is available, so unattended operation is absolutely available. Also included in the VQuad probe is a watchdog service, hardware-based, so in case issues do arise with the hardware, it can automatically be restarted with the software reloaded and the test restarted as well. Some highlights of the next generation Dual UTA. So basically, it's a smaller design with added external indicators for GPS, PPS, and self-test for hardware initialization. We also improved the embedded FPGA to support more functionality now and in the future. We maintain low power, so the Dual UTA requires no external power. It gets all its power directly from the USB. So in fact, we tested 6 Dual UTA HD devices, all running Bluetooth, which takes a little bit more power, connected to a single VQuad system with no issues. So this Dual UTA also includes loopback functionality for both the 2-wire and 4-wire interfaces. So in other words, the Dual UTA has the ability to support internal loopback. From the VQuad software, you can configure the Dual UTA to loop back for instance, the incoming side of side 1 to be transmitted out the outgoing side of side 1 or the outgoing side of side 2. So you can loop back directly on side 1 to side 1 or side 1 to side 2. And the loopback can have either no delay or a delay of 500 milliseconds. This allows a little bit more flexibility for different types of tests and supporting round-trip delay measurements and self-tests. So we can actually do a self-test of the Dual UTA without cabling. Finally, the new Dual UTA includes the new 2-wire analog FXO board, which supports as I mentioned earlier, the wideband voice, along with call ID, call waiting. So it actually includes standard call ID and also call ID through call waiting. And we also have additional flexibility with the loop current drop. So the loop current drop actually determined or tells us that the far end call has dropped off. And with the previous Dual UTA, when we got loop current drop, we were waiting for the loop current to actually go down to 0. With this new Dual UTA, we can actually specify how much of a loop current drop we want, and then disconnect the far end call, or determine that the far end call was disconnected, I should say. So this gives us a little bit more flexibility, and it allows us to work with gateways and ATAs and so forth. The enhanced FXO on this new Dual UTA also supports all countries by simply selecting from the VQuad software. So in other words, you can specify a country and change the impedance of the FXO interface. The VQuad software, as I mentioned earlier, was released as 8.0, This was to support both legacy Dual UTA and next generation Dual UTA. In fact, both can run simultaneously on the same system. So you can have both the old Dual UTA and the new Dual UTA. The latest VQuad can also support up to 6 Dual UTAs, as I mentioned. So in other words, 12 fully independent devices. Automation is achieved using the VQuad scripting, which includes full access to the Dual UTA hardware and the hardware registers, so you can pretty much do anything. VQuad also supports full remote control capabilities, including remote from a CLI or from our web browser we call WebViewer, and remote from one VQuad controlling another VQuad. So one VQuad can control another VQuad for synchronization. This is all built within the VQuad script. This version of VQuad also introduces a couple of new functions, such as the audio analyzer, which I mentioned earlier, and this for determining power and the frequency of any audio file, whether the audio file is narrowband or wideband. It includes a new function for one-way delay using a correlator method. So this new method for one-way delay actually now supports VAD or noise suppression, which on occasion caused our old method of one-way delay using pulse a bit of a problem. So now we don't have that problem. VQuadsoftware also supports VQT measurements directly from within the VQuad script. So results of the VQT measurement can be used as part of the VQuad script conditional statements. In other words, if the VQT score passes or fails, you can take different paths within the VQuad script. And then finally, the VQuad script fully supports the GL net test or data testing capabilities and our video conference testing capabilities. So I'll get into a little bit later. So this is just an example of the VQuad software that controls the Dual UTA and setting up 12 interfaces, different types of UTA. So on the UTA side, we have the ability to set up balanced or 4-wire analog, 2-wire analog, which is the FXO or simulating an analog phone, phone handset, basically again replacing the handset of any phone at the curly cord, PTT or push to talk for mobile radio, mobile, which is actually we're going to connect directly to any mobile phone as a wired headset, or Bluetooth connecting to any mobile phone as Bluetooth. So these are all the different types of interfaces available, and they can, as you configure all this, for instance, if you set up 12 devices, all 12 devices can be running independent. So they can be testing against each other within the same system or testing against other VQuad systems as the two endpoints. This is just a screen of the remote control using the CLI. So actually any application that can access the CLI, like Tickle, for instance, can use this for full remote control of the VQuad system. And there's pretty much everything is available here: loading a script, running the script, stopping a script, making a call directly from the CLI without the script, getting result files. So a lot of functionality, a lot of capability directly from the CLI itself. And finally, we have remote control directly from our WebViewer, which is our web browser controlling the different VQuads. So here you can again load a script, run it, stop the script, load parameters associated with the script, all from just a web browser. Okay. So the VQuad solution offers an abundance of KPIs when running automated scripted tests. APIs include call control based on pass-fail events, such as how many calls were placed, how many calls failed or how many calls prematurely dropped. All these can be added to the central database. Setup time or post-dial delay is available. We're also looking into adding other timers such as wait time before ring and time before answer. Voice quality metrics, including the MOS associated with either Polka or PESC, along with the signal and noise levels of both the reference and degraded voice files. These are all available. Time jitter and front-end clipping are also reported from the VQT algorithms. A few methods are available now for one-way delay and round-trip delay measurements, as I mentioned. So either using the pulse method or this correlator method, and these are also reported as KPIs. And then, as mentioned, the audio analyzer can be run from within the script and provide the RMS power of the voice, along with frequency response, so that basically an indication of whether it is narrowband or wideband voice. And as part of the VQuad solution, we can also support data testing using our GLNet test or video conference testing. And the data and video KPIs include a variety of metrics associated with each different type of tests. So in other words, in the data testing, we have a test called TCP. And here we can provide metrics such as, or KPIs such as effective speed, delay, and number of retransmits. Another test called HTTP test includes latency, connect latency, find latency, read latency, number of bytes read, average read time, failed rate. So it also includes a bunch of different KPIs. So each test provides specific KPIs associated with that test. We have an SMS test, and that includes KPIs for the time, the amount of time for sending and receiving the SMS, along with the number of SMSs sent. We do the same thing for email testing. The video conference test includes KPIs for the video MOS and the audio MOS, along with packet loss, packet discard, and paired frames, just to name a few. All KPIs, whether for voice quality, for data, or video quality, can be sent to our central database and then output as tabular or graphical as you access the WebViewer. Okay, so now let's look at a few typical test scenarios. Okay, so testing any mobile phone can be accomplished using the Dual UTA Bluetooth interface. Both call control and voice are supported, making this a fully automated operation. And with wideband Bluetooth, VoLTE can be fully tested for both voice quality and one-way delay measurements. And since the Dual UTA HD is phone and network independent, any mobile device can be connected and any network can be tested. We don't care. We can test pretty much anything. Without any modifications or enhancements, the VQuad with Dual UTA HD board can test 2G, 3G, 4G, voice over LTE. In fact, the solution is right now ready to test the upcoming 5G networks. We just need 5G phones. We're ready to test. Two-wire analog FXO testing using the Dual UTA HD now supports both narrowband and wideband for HD testing, especially when connected to VoIP gateways. Full call control is supported for fully automated test scenarios. Additional features include the call ID reporting, loop current detection, flash hook, sending and detecting DTMF digits, So basically, two-stage dialing or any supplementary service within two-wire networks can be executed and tested. And with the two-wire also, by the way, again, we support any country, any location, any type of call progress tones as well. So we've tested it all over the world. The Dual UTA also includes several four-wire analog interfaces, including balanced, which can replace any analog headset. For example, test Skype from the PC by connecting the Dual UTA HD directly to your PC headset interface. You can also connect the Dual UTA to a mobile phone such that the mobile phone detects the Dual UTA as a wired headset with both TX and RX functionality. The Dual UTA can replace the handset of any phone at the RJ22. If you're testing the phone itself, or if the only method to get into the network is through the physical phone, you can use the handset interface on the Dual UTA. So in certain cases, whether it's a BRI phone or it's an encrypted government phone, rather than trying to get into the network, we can go right through the physical phone, connect at the RJ22, and then test voice as well as delay measurements and other metrics. The Dual UTA can also connect to any mobile radio and provide both audio as well as the necessary push-to-talk connectivity for fully automated radio testing. So connect to any mobile radio. We can key the radio, send voice, and at the other end record voice, and then swap, unkey the first radio, key the second radio, and send voice in the opposite direction for voice quality. And all interfaces obviously include support for voice quality testing and delay measurement testing. The VQuad can also support setting up or configuring as a VoIP SIP user agent to establish SIP calls with RTP traffic. In this case, the Dual UTA is not required. Rather, the VQuad uses the Ethernet port of the VQuad PC. So the user has full flexibility to specify the audio codec, as well as connect to the SIP with the registrar and so forth. So all those parameters are available. Obviously, both narrowband and wideband codecs are fully supported. Since the VQuad can be configured for up to 12 simultaneous devices, you can actually configure some devices using the Dual UTA HD interfaces, while other devices are set up for SIP user agent connectivity. And all devices, as mentioned, will be running simultaneously or with whatever method you want, because they're all independent. So the VQuad can absolutely be used for mobile drive testing, either a mobile-to-mobile test or a mobile-to-a LAN interface. Both ends of the call can run automated as well as remote controlled for fully unattended test environment. So again, an unattended test environment, which means you can put the VQuad system or VQuad probe in the car and actually remotely tell the VQuad to start and just let it run. So you don't need two people for the test, one person driving, one person attending the hardware or the software. You only need one person for driving, and the VQuad solution can just run by itself. And then with the optional GPS receiver, all events, all results are all stamped with the GPS coordinates, and then all this information goes into the central database and can be plotted in Google Maps to show what the results are or show different patterns of how the drive test went. Using the VQuad with the Dual UTA, along with the optional GL net test and GL video conference testing, voice, data, and video can be tested from the same mobile devices when using the VQuad scripting. The GLNet test, as mentioned earlier, includes a variety of different data tests. This includes TCP, UDP, HTTP, VoIP, FTP, DNS, SMS, email. So all these different types of tests can be run directly from either an Android or an iOS device. We basically have an app for it. And then you can either run the test manually from the device or automate it through this scripting. The video conference testing can be installed on any Android device as well as any Linux or Windows PC. This solution tests video between two endpoints or agents with MOS provided for both video and audio. So test scenarios can be configured including video resolution. For the video testing, we can set up video resolution, the codec, the frame rate, basically to get a truly realistic video test. And since the video and data tests don't require any equipment, just the mobile device, these tests can be run anywhere and any time with the phone pretty much just in your pocket or in the car. You can actually be on a call or on the internet of the phone, and we can still run our tests. So in essence, you can be running, again, if the phone is connected to the VQuad through the Dual UTA, you could be running voice, video, and data within a call simultaneously. So finally, why do I need functional testing? Every time a new software change or a hardware tweak or any other network type of change, the system requires full regression testing. In other words, fully automated testing of the entire system using the same parameters where we can compare these results with past results. So we can create a series of scripts for testing different scenarios, for instance, a VoLTE, testing both voice and delay, and connecting to a variety of different mobile handsets. If new mobile handsets come out, we can run the same exact tests. With each new revision of the VoLTE network, and as additional sites are added, expansion of the VoLTE network, regression tests will take a major role. And as we deploy the 2-wire HD, as it's being deployed, we can perform regression testing in each step of the way. So regression testing is extremely important, and we can support that fully with our VQuad scripting. So what happens to the quality, either voice or data, when there's a load on the network, or when we're on the device during peak times? Testing under low load, normal load, and high load is critical to confirm what the network can handle and if additional precautions are needed within the network. And again, we can fully support these type of tests. Keeping on that same line, running long-term tests to confirm stability of the network. Does the network maintain connectivity? What if we leave the call up for extended periods? Can voice quality be maintained? And does network sustain high-definition voice throughout? Again, very important. Testing throughout a geographical area, rather than just testing in a static location, is required to confirm fluid operation include proper handovers within the mobile network. Will the call sustain the VoLTE network? Will the LTE data speeds be sustained while traveling? Are there any holes or low points within the network? Keep in mind, drive tests are not limited to driving around town with the test equipment in the car. Rather, this can also include walking around with our NetTest app running on your mobile device, or putting the system on a train or a bus or a boat, running the system on subways. Practically any means of mobile type testing are supported. And with the data and video app running with a all-in-one standalone VQuad probe, testing in any environment can be accomplished. So again, using the VQuad probe placed in any location or placed in any vehicle and just running unattended, while also providing the video and data apps, can provide can support full testing of the network. Have you ever gone to a large event or a sporting event or a concert, tried to access your phone for voice or data? Depending on the venue and when you try to access the phone, you might be out of luck. For instance, in a sporting event, at a halftime, or at the end of a period, and everybody has nothing to do but access their phones, there may be connection issues. Using our testing for voice and data, we can determine if the sports arena might need to expand their cell capabilities to support higher percentage of users during these peak times. So whether we're using our app itself and placing the phones in different areas of the sports arena or the stadium, or if we're using our standalone VQuad probe and placing it in different areas, and pretty much all we need is power for that, we can gain quality measurements and then determine what needs to be done to expand communications within this arena. Okay, so to recap, the GL solution provides end-to-end testing of narrowband and wideband voice, and basically it's the true user experience. So the Dual UTA replaces the mouth and ears for testing at the endpoints. Several interfaces are available from the VQuad solution for connecting to most any equipment or any network, while supporting both narrowband and wideband audio along with full automation. Multiple tests can run simultaneously with a wide variety of KPIs generated and reported to a central database. All results and all events and all errors are accessible using our WebViewer, as they're all placed in a central database. Query and filter the results, output the results to file or to graphic, plot the results to Google Maps using color-coded pins for showing the pass and fail. And of course, both data and video testing is also available to run alone or to complement the voice testing. The data and video tests can be run manually or directly from the mobile device, or automated using the VQuad scripts. That's the presentation. Well, again, if any more questions or comments, or if anybody wants to see demos of any of the solutions discussed, just let us know and we can arrange. And thank you very much.